Hello guys, welcome to Samaliaki YouTube channel, and today we are going to learn about transistors. Transistors are electronic devices which are used for amplifications. So this is a very important electronic device which is used for amplifications. So what is amplification? Amplification, we say this is a process of increasing magnitude or strength of signals. We have also the types of transistors. We have bipolar junction transistors and field effective transistors. So in our level, let us start with this bipolar junction transistors. What is this bipolar transistor is the kind of transistor which is formed when we add a PN. Because you have this PN, then if this PN is added N or P, it is called a bipolar transistor. Now we have two types of bipolar transistor junction. One is we call PNP and NPN. These are the bipolar transistor junctions, and we can draw this. For example, this is PNP. Also, we can draw NPN. These are the two bipolar transistors. But in these two bipolar transistors, we can also draw in other terms simple like this ones. This way. What to note, how to differentiate the collector and base. Always emitter is pointing in or out. For example, this is emitter, so it is designed where the current will start, so this is pointing in, or sometimes it can point out. So in this circuits, we know this is base, this is emitter, this is collector. Also this is base, this is emitter, this is collector. So we have the three terminals of transistors, whereby we have base, emitter, and collector. This one, as you can see here, but not the following. Emitter point in or out. This one, as you can see here, it is how can you differentiate collector and emitter? These ones. Also, another issue is we can draw also the diagram, the full diagram of this PNP or NPN. These ones. For example, this is PNP. Now, in this PNP, we can put this one. Now we can select it. For example, here, if you put the positive terminal here, this is the positive terminal. So this loop is forward biasing because the positive terminal is connected to the P types, and this side, this is reverse biasing because in this one the negative terminal is connected to the P types. So this is example of a bipolar transistor, and we know also from the concept of here, we know from Kirchhoff, we know if this emitter is getting out, automatically this all will get in this one. So IE is equal to IC plus I base. Note this formula. Configurations of transistors. Transistors can be configured in three ways, whereby we have common base, common collector CC, and the common emitter. These are configuration or connection of transistors. Now let us start with this common emitter. In this common emitter, it means this emitter is connected to the input and the output side. Now we can find the gain here. Let's start with current gain is equal to I output over I input, this one. But here we have the current this current is pointing this direction. If emitter is pointing in, automatically the rest will point out. So this one, this will get out. This is IC, and this one also will get out. This is I base, this one. So we have IC, I base, and the IE here. Now we can find the current gain here. Current output, we know it is IC. Current input IB. So I gain is equal to IC over I base, but I gain is denoted by the diagram which is we call beta constant. So beta is equal to IC over I base. Also we can find the voltage gain, which is V output over V input. Now refer here, because we consider this is V output, which is VC, this is VCE, this one, this is emitter, this is base, so VBE, this one, VBE. So V gain is equal to V out. We know V out is VCE over VBE. This is voltage gain. Also we can find power gain is equal to IV output over IV input. But we know I output times V output over I input times V input. We know exactly what is I. It is IC times this one, voltage output. We have already denoted here VCE over IB times V, this one, BE. Also we know what is this one. This is beta. So power gain is equal to beta times voltage gain, this one. Also we can express in other terms of resistance, because we know power is equal to I square R here. Now power gain, it will be I square output times R output, which is load resistance, over I square input times R input. Yeah, so also we know this is beta, so power gain is equal to, this is beta square times RL over R in. This is common base. In common base we know also this is VE, and this is base, so VBE. Here this is C and D base, so VCB, this one. Also we can find current gain. I gain is equal to I output over I input, current input. But we know what is current output. It is IC over input. This is input, this one is output. So we know what is current IE, this one. So current gain is equal to IC over IE, this one. But we know this current gain, it is denoted, I gain is denoted by alpha. So alpha is equal to IC over IE. This is current gain. Also we can find voltage gain. V gain is equal to, we know it is V output over V input. We know what is V output. It is this one, VCB over VBE. We can also find power gain, which is power power output over power input. We know what is power, IV, but we know we call this is at where output input. So it is IC times VCB over IE, this one IE times VBE. So that is power gain. Common collector, it means collector is occurring at output and input, this one. So we can find also current gain. I gain here is equal to IE over IB, because it output over input. Also this is I gain, it's denoted by gamma. Gamma is equal to IE over I base, this one. You can also find the voltage gain and power gain. Now let's check the relationship between alpha and beta. These are current gains. For example, for a common emitter, beta is equal to IC over I base, and for a common base, we know current gain is equal to IC over I. This is IE, this one. Now we can show the relationship between this one and this one. Okay, let's start here. We know alpha is equal to IC over IE, but we know also from here we can make the subject here. We know IC, it will be beta IB, so you can substitute here. So alpha is equal to IC, which is beta I base over IE. But also we know what is IE from Kirchhoff. IE is equal to I base plus IC. Now you can substitute here. So alpha is equal to beta, then I base over I base plus IC. Yeah, this one. But also if you can see here, we know this IC is this one. So it is alpha is equal to beta, then I base over I base plus beta I base. Yeah, now I base is common, so alpha is equal to, then is alpha times I base over I base is common, then 1 plus beta, this one. Now you can see I base and I base will cancel, this one and this one. So alpha is equal to beta over 1 plus beta. So this is the relationship between alpha and beta. Now let's check the relationship between base current gain, beta and alpha. This is for current gain for a common collector. So gamma is equal to IE over I base, this one. But we know also what is I beta is equal to IC over I base, this one. So you can make the subject this one. So IC is equal to this IC beta IB. Then this is equation 1. Now refer to this one. This one is equal to IE over I base, this one. But we know also from Kirchhoff, IE is equal to IC plus I base. So you can substitute here. This one is equal to IC plus I base over I base. But we know the value of IC, this one. So substitute here. This one is equal to, then beta I base plus I base over, this is I base, this one. Now this IB is common, so it is I base, then this is beta plus 1 over I base. So I base and I base will cancel, so alpha is equal to beta plus 1. Thank you very much guys for watching my channel. Don't forget to subscribe, like, comment and share so that we can get more and more concepts about physics and other science subjects. You are most welcome.